Hi guys. So in this video, let's cover something called the additive smoothing. All right. This is used in the knife-based algorithm. I'll tell you why it's used. I'll take an example. Let's say we have a training data set. All right. Training data set, and for simplicity, let's just assume that it has five words: word one, word two, word three. Let's just assume it has three words for simplicity. Okay, and there are two classes. The classes can be either 0 or 1. Okay, for classification. Now, so when I want to calculate the probabilities, I'll calculate it something like this, right? Py equals 1 given w1, py equals 1 given w2, probability y equals 1 given w3. Similarly, I'll also calculate for the cases when y equals 0, right? Because as we all know from the knife Bayes formula, the derivation that I did in the previous video, that uh, the final probability is just the multiplication, right? Okay, so what happens? So in English, right? Words, if you use the English language, it can so happen that there is a word in your test data that is not there in your training data. Let's call that word w dash. So when you have to calculate the probability that the text corpus belongs to class 1, you would calculate it something like this: probability of y equals 1 into probability of y equals 1 given w1 into probability of y equals 2 given given w2 into probability of y equals 3 given w dash. Okay, let's assume that in the test corpus you got words w dash, w1, and w2. So if you want to calculate the probability that all of this text belongs to class 1, this is how you would do it. This is the formulation for for the knife Bayes theorem, right? For the knife Bayes classification model. And if you look at this formula, it's easy to see that there's a problem with it, right? The problem is that W dash did not occur in our training data. So we don't have a value to put over here. Probability of y3 equals W dash. Now, people would what would you do in this case? Some people might say that you give this value a 0 because W dash wasn't there in the training data. But it's easy to see that we can't give this the value 0 because if you give this 0, then this entire thing becomes 0, which is meaningless. Because you're multiplying the probabilities, right? So you cannot give it 0. What about if you give it the value 1? Let's say that someone comes and they argue that we give it the value 1. What happens then? In that case, that might seem like a good way to go about it, but when you give it the value 1, you need to realize that what you're essentially saying in mathematical terms is that the word w dash, this word w dash, occurs in each and every uh sorry, this is 1. It's not 2 and 3. This is 1. So when you give it the value w dash, what you're saying is that this word occurs in each and every text corpus where the class is 1 in the training data set. Now, again, that's incorrect, right? Because W dash can be something very esoteric, or a very less known word, in which case it should be given appropriate importance, right? Uh, so, to overcome this, we use something called the additive smoothing. I'll explain what that is in a minute. I'm sorry that I wrote 2 and 3 over here. This is supposed to be 1. There are only two classes, 0 and 1. So additive smoothing, what it does is, let's just consider this case where you have probability of y equals 1 given w dash. Okay, so what additive smoothing does is, so in general, you would have 0 upon n, right? Because the number of times where w dash occurred in all the text corpuses where the class is equal to 1, upon the number of times, upon the probability that the number where the class is equal to 1. So this is like probability where class is equal to 1 upon total number of, upon all the data points, right? So this is 0 plus 0 upon n. So what you do over here is you add something called the alpha on the numerator, and you add alpha k in the denominator. Okay. So how you go about this is k is basically, what is k? K is basically the number of different values that w dash can take. Okay. What does that mean? K in this instant will be 2. Okay. Because w dash can only take two values. W dash can either be present or it cannot be present. Right? That is the value of k. Now, if this wasn't w dash, if this wasn't a word, if this was, let's say, an ordinal value like 1 comma 2 comma 3 comma 4, and let's say in those ordinal values in all your training data there's 1 2 3 4, and there's an ordinal value, that 5, that comes in your test data. So k in this example would be equal to 4. Okay, k would be equal to 4 because there are 4 different values that the ordinal data could have taken, but it took 5, right? But in this case, w dash can either be present or not present. So that is the different values that w dash can take. So k will be equal to 2 in this case. Okay. And a is what you call the additive smoothing coefficient. So what you do is, if you use something like sklearn, you have an option to set the additive smoothing value, right? And alpha, what you do is you do something called hyperparameter tuning, where you take different values of alpha. Alpha equals 1 comma 2 comma 3, or it can also be 0.0001, anything, depending upon the type of problem that you're trying to solve. You would ideally take a range of values of alpha, and you would try where you for all of these values of alpha, you would try to observe where you get the best possible uh, value for your performance metric for that particular value of alpha. So you're basically going to hyperparameter tune it using the values of alpha. Now, what you need to understand is that taking alpha can the value of alpha that you take decides the sort of importance that you want to give that word in your problem that you're trying to solve, or in your model that you're using, which in this case is the knife based model. So let's just assume that, if I take, if it's 0 and n is, let's say, 5, and if I take the value of alpha as 5 and k is 2, so this is 10, so this becomes 5 by 15, which is equal to 1 by 3, right? What this basically says is that I'm giving alpha as a value where I'm giving it a very high importance over other words. Because if the value is 1 by 3 over here, that means you're giving this word a very high importance. So if the word is very esoteric, which is relatively very less known, and that appears only for a very specific class, you can give it a very high value, right? So if let's say the word is some very complicated word, let's say it is arduous, right? And you see that if you observe your data set, you see that arduous comes only where the value of y is equal to 1. So you would ideally want to give alpha a very high value, because we know from our training data set or from our test data set that, not from our training, from our test data set, that arduous is a very esoteric word and it comes very rarely. So I want to give it a very high value so that whenever it comes, my classifier identifies the class correctly as 1. Okay. Similarly, if you give it as 1 by 2, what you're basically saying is that no matter where it comes, whether it comes in 0 or 1, it should be given, no matter where it comes, in whatever class it comes, in 0 or 1, it should be given equal importance. So if you give an alpha, the value is something like where this happens to be 1 by 2, you're giving it an equal value for both classes, 1 or 0, right? So this is what I wanted to explain about additive smoothing. It's a very important concept, and it's used in a lot of classifiers with different names. It's called additive smoothing and knife bias. It's called something else in some other classifier. So we'll continue in the next video.